Hello, and welcome to my channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This is the second of 6 videos in a playlist on ANOVA and related concepts. Depending on when you are viewing this, the others may not be available yet. To get the latest status, see the videos page on the book's website. First, let's recap what we learned in the Part 1 video. ANOVA compares the means of several groups with each other. A group is a set of data. It can be all the data in a population or process, but usually it's a sample of data from a population or process. ANOVA can tell you whether there is a statistically significant difference among one or more of the group means, but it cannot tell you which means are different. How does it do that? This concept flow diagram depicts what goes on behind the scenes in an ANOVA, and we'll be going through it in detail in this video. But you probably don't need to worry about executing these steps yourself. Spreadsheets or software will do all the calculations for you. Briefly, here's what happens. For each group, a sum of squares between, SSB, is calculated, and for each group, the sum of squares within, SSW, is calculated. As we'll see later, SSB and SSW are both measures of variation. Next, the mean of the SSBs is calculated. This is MSB, the mean sum of squares between, and the mean of the SSWs is calculated to be MSW, the mean sum of squares within. MSB and MSW are also measures of variation. In fact, both are a type of variance. Now, if you divide two variances, such as MSB and MSW, you get the test statistic F. With a test statistic, we can do a hypothesis test. We select a value for alpha, the level of significance, usually 5%, and this gives us the critical value of F critical. We compare F to F critical to determine the conclusion of the hypothesis test. Either there is a statistically significant difference among the means of the groups, or there is not. Several terms in that conceptual illustration of the ANOVA method are different types of sums of squares. First of all, what exactly is a sum of squares? Sum of squares is short for sum of squared deviation. And what is a squared deviation? Well, for any individual value of x in a group, its deviation is its distance from the mean of the group. Deviation is defined as x minus x bar, where x bar is the mean of the x's in a group. Each deviation is squared to eliminate negative numbers. This is the squared deviation. There is one squared deviation for each value of x in the group. Then the generic sum of squares is the sum of these squared deviations. We said earlier that a sum of squares is a measure of variation. As you can see here, a sum of squares is the numerator of the formula for variance. Variance is the square of the standard deviation, which is the most common measure of variation. Okay, we now have enough background in sums of squares so that we can go forward with some keys to understanding, or KTUs, of how ANOVA does what it does. There are 5 KTUs. The first states that, number 1, the sum of squares within SSW is the sum of the variations as expressed by the sum of squares within each of several groups. Here we have pictured 3 groups as distribution curves, and we've conceptually illustrated the variation within each group by the width of the horizontal line segments under the curves. You can see that the variation within groups 1 and 2 is relatively small, while the variation within group 3 is relatively large. The 3 variations are totaled up to give us the SSW, the sum of squares within. Here is the second key to understanding. The sum of squares between, SSB, measures variation between or among the groups. An overall mean, X double bar, is calculated for all the data points from all the groups. Then for each group, the deviation of the group mean from the overall mean is calculated. The deviations are squared, and the sum of the squared deviations is the sum of squares between, SSB. And the total of the variation for all the groups is defined as the sum of squares total, SST. SST is the total of both types of variation. That is, SST equals SSW plus SSB. Here is the third KTU. MSB is the average of the SSBs, and MSW is the average of the SSWs. In our example, we have 3 SSBs and 3 SSWs. But now we distill the information from those 6 statistics into only 2 statistics, MSB and MSW. This is useful in getting a test statistic F by dividing MSB by MSW. But in converting 6 statistics into 2, we have lost information. We have lost the individual identities of the 3 groups. In the steps in the ANOVA process after the calculations of MSB and MSW, there is no way to tell which data came from which group. That is why ANOVA can tell you whether there is a statistically significant difference, but it can't tell you which group or groups is different. You would need a different tool, like ANOM, A-N-O-M, to tell you that. And here is the fourth key to understanding. We showed earlier how the sum of squares is the numerator of the formula for variance. The formulas for mean sums of squares are similar to the formulas for variance, so we can use them as variances in the formula for F. F is the test statistic, which is simply the ratio of 2 variances. So now we have a value for a test statistic F, and so we can do a hypothesis test. In a hypothesis test, we select a value for alpha, the level of significance. Most commonly, alpha equals 5% is selected. This value for alpha, plotted on the F distribution, gives us the critical value of F critical. We compare F to F critical to come to the conclusion of the hypothesis test. If F is greater than or equal to F critical, then there is a statistically significant difference among the means of the groups. If F is less than F critical, then there is not. Here is the complete list of keys to understanding the concept of how ANOVA does what it does. You may wish to pause the video here and read them all together. This is a list of related videos which I have planned. Depending on when you are viewing this video, some of these may not yet be completed. See the videos page of the book's website for the latest status. Okay, that's it for our clarification of this confusing concept. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me that more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website, statisticsfromatoz.com, has a listing of available unplanned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website. I'd recommend you follow my blog at statisticsfromatoz.com/blog. I've got some things there that hopefully you'll find interesting, like a Statistics Tip of the Week series, as well as posts showing that you are not alone if you're confused by statistics. I'll also be posting on the Facebook page Statistics from A to Z and on Twitter as @StatsA to Z.